All right, guys, we are on day 4 of our Unit 9, and we're going to talk about volume of cones today. All right, their bottoms look like cylinders, all right, except we don't have a circle on top with straight lines going up towards it. And so we end up forming a cone instead of a cylinder. Main difference is that cylinders have 2 bases. Okay, top and bottom are both circles, and a cone only has 1 base that is also a circle. All right, so in our warm-up, it says find the radius of a cylinder with a volume of 208 pi centimeters cubed and a height of 4 centimeters, and write your answer in what they call simplest radical form. Okay, so again, our shape is a cylinder, so let's make sure we're talking about the correct shape. All right, let's give ourselves a visual so we don't use the wrong formula. Okay, and they said that the height of my cylinder is 4 centimeters. And they're asked us to solve for the radius. Okay, and they gave us the volume. So we know that our reference sheet has the volume formula. So we'll say volume of a cylinder is pi r squared times height. They told us our volume is 208 pi. So volume comes out and 208 pi goes in. Equal to, pi stays on this side. We don't know the radius. That's actually what we're solving for. So we'll keep it r and make sure you square it. And the height gets replaced with 4. All right. The other day when we learned cylinder, we realized that if there's a pi on the left side and a pi on the right side of the equal sign, that they're actually going to cancel. Okay, and then we're going to rewrite it to see what we have left. So we have 208 on the left-hand side equal to r squared times 4 on the right-hand side, which is really 4r squared. We're going to go ahead and divide by 4 to get r squared by itself. And 208 divided by 4 is 52. Okay, we're going to go ahead and square root so that we can get r by itself so we can solve for the radius. And square root of 52, guys, would be a fine answer, except the fact that they said write your answer in simplest radical form, and 52 is not simplified. There is a large perfect square that goes into 52. We just have to make sure that we find it, all right? And the largest perfect square that goes into 52 is 4, and it goes in 13 times. And we know that the square root of 4 is actually 2. And we'll keep the square root of 13, and that is our radius. Everything's labeled in centimeters, and our radius is just 1 dimension, so we'll say 2 square root of 13 centimeters. Okay. All right, let's go ahead and talk about the volume of a cone. Again, a formula is given to you on your reference sheet. It's very similar to the volume of a cylinder. In fact, the only difference is this big 1/3 that's right here. So if you fill up a cylinder and you fill up a cone that has the same circular base, same size circle, you're going to realize that you're going to have to fill up 3 cones in order to fill up the cylinder that has the same circular base. Okay, everything else stays the same. There's still a pi in there, still r squared, and still height. Okay, one thing we do have to remember is that the height, okay, has to be perpendicular to the base. So when we talk about the height of a cone, it goes from the tippy top, called an apex, okay, straight down. All right, it has to make that right angle with the base or with the radius or with the diameter. Okay, now if they give you this dimension right here, that's actually called slant height. Okay, you can see because it's a height slanted. That slant height actually has a longer length than the actual height because that slant height is actually the hypotenuse of our right triangle, known as the longest side. All right, so again, the distance along the outside of the cone from the vertex to the base is called our slant height. If we're given that, we can't use that as our height. Okay, we'll have to go ahead and use Pythagorean theorem to figure out our height from the slant height. All right, let's see how we do. So in number 1, it says in the diagram below, we have a right circular cone. Okay, so right just means that the cone is standing straight up, not leaning. Circular because it has a circular base, okay, and cone. So really we just have to pick out this word out of those 3. It has a diameter of 8. And if you remember from the other day, this formula does not use diameter, it uses radius like the cylinders does, okay? So instead of having 8 here, we're going to go ahead and chop it in half so that we can get 4 as our radius so that we don't misuse in our formula the 8. Okay, we have a height, and this height looks like it goes straight up and down, and so we can definitely use 12 as our height. That is not a slant height. Okay, what is the volume of the cone to the nearest cubic inch? So we'll go ahead and say volume equals 1/3 pi r squared times height. They want to know the volume, so we'll leave the v open. We'll keep the 1/3. It's part of the formula. We'll keep the pi. Okay, and then the radius we already determined is 4. Formula says to square it. And then the height, which we said is straight up and down, and so that counts as a height, not a slant height, is 12. Okay, now because they said nearest, that means all of this goes in. All right, so one thing I would recommend is that this 1/3 is entered in parentheses times your pi, which you have to hit your second and your caret key to get. 4 squared, you can type in, or you could type in 16, and then times 12. All right, so that's how you would type it into your calculator. And your volume is going to come out to be 201.0619 ... Okay, because they want nearest cubic inch. Notice there's no 10th word, no 10th, 100th, or I should say no th word, no 10th, 100th, 1000th. All right, so that's no decimals. And so we're rounding the 1, but we have to look next door at the 0, and it's not going to round it up. And so we're going to go ahead and say that our volume is 201 not centimeters. We're not in centimeters in this question. Okay? We are in inches. Okay? So 201 inches. And volume is labeled in units cubed, so inches cubed. Okay. All right, let's take a look at number 2. Number 2 says that we have an ice cream waffle cone. Can be modeled by a right circular cone, okay, with a base diameter of 6.6 centimeters and a volume of 54.45 pi cubic centimeters. What is the number of centimeters in the height of the waffle cone? Okay. So in order to draw a cone, and cones can be drawn either the way we just had them here or upside down, where the circle's on the bottom. But because this is an ice cream cone, most of the time it's going to look like that first picture. So we draw an oval or ellipse on the bottom. Straight down from the center of that circle, I put a point here, and I use that point to connect the two sides of the ellipse too in order to get that cone shape. Okay. Now we got to go back and label. It says an ice cream waffle cone could be modeled by the cone, okay, with a base diameter. So again, they said diameter, guys, and I'm not going to go ahead and use that 6.6 in my picture because my formula doesn't use any diameters. It always uses the radius, and radius is half the diameter, and half of 6.6 is 3.3. And that's in centimeters. It says it has a volume of that, so we'll use that in a second. And what's the number of centimeters in the height? Height, remember, goes from the center there to the tip of the cone, and we don't know what the height is. Okay, all right, so formula for a cone is volume equals 1/3 pi r squared times height. Now they did tell us our volume, so when we take the v out, we're going to put in 54.45 pi equal to 1/3 pi. Your radius, we already cut in half from what they gave us with the diameter, and it's 3.3. Don't forget to square it. And then the height, we don't know, so we'll leave it h. Okay. Remember from the couple problems that we've done so far that when there's a pi on the left side and a pi on the right side of the equal sign, you're going to go ahead and cancel them. And write what's left over. 54.45 is left on the left-hand side. On the right-hand side, we have 1/3 times 3.3 squared times our height. Okay. We're going to go ahead and type in 1/3. I would recommend using parentheses around the fraction, times 3.3 squared. And when you enter that in your calculator, you end up with 3.63. And don't forget the h is there. Okay, because that h has multiplication between the 3.63 and itself, we're going to go ahead and divide by 3.63. So that'll cancel it out, and we're going to be left with our height is equal to, and it goes in exactly 15 times. And so we have 15 for our height. Everything's labeled in centimeters, so height is just one dimension, so it just gets 15 centimeters. Okay. All right, let's take a look at number 3. In number 3, it says in the diagram below, we have a right circular cone with a radius of 3, and it has a slant height of 5. So as soon as we know that that's a slant height, we're going to have to realize that we can't use the 5 in our formula, okay, when we calculate the volume. So what we have to realize is that we actually want the length of this nice dashed line segment, and we have to realize that it's going to be definitely less than 5. Okay, but if you notice, that's a nice right triangle because the height forms a right angle with the radius. And we're going to go ahead and take a squared plus b squared equals c squared off to the side. 5 is the side across from the right angle, so that makes it the hypotenuse and has to go in for c in the Pythagorean theorem. And then we'll keep 3 in for a or b, doesn't matter. Okay, 3 squared is 9. 5 squared is 25. We're going to take the 9 away from 25 so that we get b squared by itself, okay, equal to 16. And then we're going to go ahead and square root. The square and the square root cancel each other out, leaving you with b equals. The square root of 16, guys, is perfect. It comes out to be a nice 4. And now we're going to go put 4 here, and we're going to cross out the 5 so we don't use the 5 accidentally. We also have a right cylinder with a radius of 4 and a height of 6. So nothing needs to change there. We're going to determine and state the number of full cones of water that need to completely fill the cylinder with water. All right, so what that means is that we're going to go to the water fountain, fill this cone up, we're going to dump it into the cylinder, and we're going to see how many times we have to do that in order for this cylinder to be completely full. Okay, we don't want it not to be completely full, so we have to make sure that we round the correct way. All right, so here we go. We're going to have to figure out how much water fits in the cone, how much water fits in the cylinder, and then how many times we'll have to do that. So we're going to go ahead and separate, I think, our paper here. Okay, so we're going to do the volume of the cone on this side, and we'll do the volume of the cylinder on this side. Okay, so volume of a cone from our reference sheet is 1/3 pi r squared times height. The volume of our cylinder is just pi r squared times height. So back to the cone. Keep the 1/3, we keep the pi. The radius we know is 3, formula says to square it, and we already figured out that the height is 4. Okay. We could type it all in, or we could leave it in terms of pi. It doesn't honestly matter, or we can show both ways too. All right, but I think, to be honest with you, both of them have a pi in their answer, so it might be easier to leave pi in. And I'll show you what happens to the pi if we don't type them in our calculator. Okay, so let's go ahead and do this. We'll type in everything but pi. So we'll leave this on our paper, but we're going to type in the 1/3, make sure he's in parentheses. 1/3 times 3 squared, or 9, times 4. When we hit enter, we're going to get 12. But remember, the pi didn't go in our calculator, so it's 12 pi. And we're in inches. And this would be inches cubed because it's a volume. Okay, that's not our answer, so we're just going to leave it there. I'm not going to box it in yet. Yeah, on the other hand, guys, the volume of our cylinder, pi stays. The radius of the cylinder is 4, so make sure you plug in the radius of the cylinder, not the cone. Okay, don't forget to square it. And then the height of the cylinder is 6. Okay, don't use the height of the cone. Okay. All right, so pi is going to stay. And and we're going to type in everything else. Just because we left the last one in terms of pi, we want to make sure that we're consistent and leave both of them in terms of pi. Okay, so pi is going to stay on our paper. Okay, you're going to type in everything else. So you're going to type in 4 squared, or 16 times 6, and we end up with a volume that is larger, which is good, of 96 pi inches cubed. Okay, and there's our 2 volumes. So we want to know how many times this will go into that. So we know how many times to fill it. All right, so if we take 96 pi and see how many times 12 pi goes in, so it's a division problem, okay, what's going to happen is that pi and pi will actually cancel, or you can type them in, but you're going to have to use parentheses if you do type that all in, okay? And then 96 divided by 12 is 8. And we will say 8 full cones will need to be filled, dumped into the cylinder, and then it will be completely full. Okay. If it didn't come out to be an exact number, we would have had to think about our rounding. So for instance, if it came out to be like 7.92, all right, we would have to make sure that we round up to 8 so that, yeah, we're going to overflow the cylinder, but it'll be completely full. All right. If we had rounded down to 7, then our cylinder wouldn't be completely full and we would need more than 7 cones. Okay. So just to show you if it did come out not to be a full number of times going in, how you would have rounded. All right. Okay, guys, I will see you on the back side of notes.